So our topic today is forces and vectors. And we're going to use these forces and vectors that involve the law of sines and law of cosines. So let's just kind of quickly review what a vector is. We dealt with them when we talked about imaginary numbers, and in fact, that's how you graph an imaginary number. You start at the origin and you draw a line with an arrow on the end, also known as a ray, but this is what we're going to use as our vector. Now, two things we need to know about them. One, vectors give a direction. Okay, so they'll tell us what direction you're pushing or pulling in. And two, they have a magnitude. And the magnitude is going to describe the vector's length. Okay, so just kind of a new word that represents the word length. And then when we talk about the word force, basically we're talking about, are you, pushing or pulling an object. If you're pulling the object, your vector might go out this way if you were pulling in that direction. If you were pushing, you might show your vector this way coming in at you. Okay, here's how I like to think of forces and vectors. Basically, these are my two forces. Let's say you're driving along the street, a little icy, you get stuck in this ditch. Alright, so here you are, stuck in the ditch. And along comes these two nice tow trucks, and they're going to try to pull you out. This guy is pulling in this direction, so let me put an arrow on this end, and we're going to call this the force. Okay, he's pulling in a direction, so our force is giving us a direction. This red truck up here is also going to try to pull you out in this direction, so we'll put an arrow on this end, and that's another force. Okay, so they're both trying to pull you out. Where do you think your car is going to go when they pull you out? Alright, is it going to go backwards? Is it going to come outside this truck? Is it going to come outside that truck? Or is it going to go in between those trucks? Well, hopefully, as they pull you in this direction and you in this direction, your car is going to hopefully pop out in this direction. Okay, and what we call that is the resultant. So when two forces act on a body, so you have a force pulling you this way and a force pulling you this way, and when you come out, you're what we call the resultant, what happens in the end. Now, I hope that makes sense to you, that, if this guy's pulling this way and this one's going this way, you should come out between them. Likewise, even if we're talking the other direction. So now, this tow truck is going to pull you in this direction, so there's your force being pulled, and this tow truck's going to pull you in this direction. Okay, where is your car going to end up? Hopefully, your car has to end up someplace between those two trucks. And again, that is our resultants, where we end up. So what are these force and vector questions going to look like? Well, when we set them up, we're probably always going to start in the same point. So we're going to make a line here, we're going to draw an arrow out, and we're going to call this one of our forces. And then we're going to draw another force in this direction. Okay, and there's our second force. And then our resultant, like we just showed you, is going to come out in the middle. So again, we want this picture in there nice and neat. Now, hopefully you can see that this is kind of like half of a shape. I hope you're kind of getting the idea of maybe a parallelogram. So I just want to be clear, there are only two forces in the picture and one resultant. And in our math class here, we're going to make it look like a parallelogram to help us with our math. Okay, so we're just going to kind of draw those in to make it look like a parallelogram, and then we can use properties of a parallelogram. But I just want to be clear, there are only two forces. Force number 1, force number 2, and one resultant. A lot of times you're going to hear that word magnitude that we talked about in the beginning, and that's just saying how long is something, or what is its length. Okay, and to solve these, we're just going to use the law of sines and cosines. So let's set up our first example. Alright, a jet is flying at a speed of 526 miles per hour. The pilot encounters turbulence due to a 50-mile-per-hour wind blowing at an angle of 47 degrees as shown in the accompanying diagram. So they were nice and drew it out for us. That's not going to happen most of the time. Find the resultant. So there's our question. Let's box that word in or write that word down with a question mark. Find the resultant speed of the jet to the nearest tenth, so that's what we're going to round to, of a mile per hour. Use this answer to find the measure of the angle between the resultant force and the wind vector to the nearest tenth of a degree. So there's two questions in there. Let's first attack the one question. And that question was find the resultants. All right, so we're going to redraw this picture. So I may just make it nice and big. So this vector was 526, or this force. This vector of force was 50 miles per hour, and the angle between them is 47 degrees. And now go ahead and finish it off and make it look like a parallelogram. The question wants to know what is the length of the resultant. So I'm going to put an X on that side. I'm going to draw my resultant in, and again it should come out between my two forces, and put an X there. Now, I really can think of this as just a triangle problem. So for myself, I'm going to pull that triangle apart and just look at one of the pieces and label what I know. I know this side is 50. I actually know this side up here because these two sides are congruent in a parallelogram. So this is 526. And now I don't actually know any angles in the triangle, but I do know this whole angle is 47, which means I can get this angle up here. Because this is acute and this is obtuse, they must add up to 180. So just 180 minus 47 degrees. So I get an angle of 133. And again, that is this angle up in the corner here. And the question is, what is the resultant? Now, I think the only tough part is determining whether you need law of sines or law of cosines. And I always ask myself sines first because I think that one's easier. Sides mean you have the opposite pieces. So let's check. You have this angle and the side opposite, so that's one pair. But then you have this side and no opposite, this side and no opposite. So sines won't work, so it's got to be law of cosines. So remember, in cosines, what you're finding comes first. All right, so I'm finding this side x here. So I'm going to start with x squared equals, then it's my two other sides, 50 squared plus 526 squared, minus 2 times those same two numbers, and then the cosine of the angle that matches. Now x went with 133, so those two go together. And now ask yourself, is this an easy or a hard one? Is x already by itself? Well, it is. So this is just plug and chug in your calculator. And I've got 227,924.1346, blah, blah, blah. And of course that's equal to x squared. So I just need to take the square root of both sides, and I stored that into a, of course. And I've got 477, and whoops, I better check and see what it said. Rounded to the nearest tenth. So 0.4, and that was miles per hour. And there you have it. That's all our force question was. So it's just basically drawing the two forces and the resultant and just carefully identifying what you have. Now there was a second piece to this equation, so let's go back and read the question. So the second part says, use this answer that you just found to find the measure of the angle between the resultant force and the wind vector. So the resultant force and the wind vector. Now I just have to keep which one straight the wind vector was, so I'm going to go back and read. A jet is flying at a speed of 526 miles per hour. The pilot encounters turbulence due to a 50 mile per hour wind. Okay, so that is the wind vector. So you are looking for, we'll read it again, the angle between the resultant force and the wind vector, the 50 mile per hour vector. So let's go look at our picture again. I'm going to redraw it out, of course. So this was 50, 526, and 47. We just found our resultant. And I think this is where a color comes in handy. So I'm going to highlight what it said again. It said the angle between the resultant that we just found, so notice I'm using my highlighter and I'm highlighting the resultant, and the wind vector, which was 50 miles per hour. It wants the angle that you just made, and that's why highlighting with a highlighter or color is so important. It's telling you this angle here. So I know this side was 526, and I knew this angle up here was 133. And I'm going to ask myself, do I have law of sines or law of cosines? Well, I want this angle, and I know the side across from it, and I found this, and I know the angle across from it. So I think I can go law of sines, which I think is always a lot nicer than cosines. So I'm going to say it's the sine of angle x, who's across from side 526, and the sine of angle 133, which is across from 477.4 that we just found. So we've got a nice cross multiply. 477.4 sine of x. It's 526 sine of 133. Divide that 477.4 out. I get 0.805, blah, blah, blah. I'm storing that into alpha A and doing the inverse sine of that side. So I'm taking sine inverse of both sides to solve for that angle x, sine inverse of alpha A. And I get x equals 53.68, and it said to the nearest tenth of a degree. So I would say 53.7 degrees. All right, second example. Two forces act on a body at an angle of 100 degrees. So I'm going to start at my beginning point, draw one force, draw my second force, and I'm going to label 100 degrees between them because it says they act together at 100 degrees. Now, you'll notice, does that look like a 100-degree angle? And I would hope you'd say no. This is an acute angle, which is less than 90. So technically, this angle should look obtuse. And I'm going to redraw it so it looks obtuse, and there's my 100-degree angle. Keep reading. The forces are 30 pounds and 40 pounds. So one gets labeled with 30, one gets labeled with 40. This one looks longer. I'm going to put my 30 there and my 40 there. Find the magnitude of the resultant force to the nearest tenth of a pound. Now remember, the resultant shoots out in between them. Okay, so that's what I'm finding. I'm going to put my x there. And I'm just going to draw in the rest of the parallelogram. Okay, so remember, we want to make it look like a parallelogram. But I only have two forces. Now, let's label any sides we can. I know this side is also 40. And I do know that if this whole angle is 100, that tells me this angle up here. Remember, they add up to 180. So that tells me this angle is 80 degrees. All right, so then I'm going to pull it apart because I think it's easier to see as one triangle. I've got a 30 side, a 40 side. I know this angle's 80, and I know they asked for this. Notice I don't put 100 in the picture at all because 100 isn't either of these angles. It's the total of them. And another note to self, this resultant does not bisect the angle. I cannot say 50-50. Doesn't cut it in half. Another geometry property. All right, so are you staring at law of sines or cosines? Well, check for sines because it's the easy one. Angle, side opposite, but then I don't have another angle and side opposite, so sines will not work, so I've got to go cosines. So I'm finding this side, so finding comes first. Your other two sides, 40 squared plus 30 squared minus 2 times those same two numbers. And then cosine of the angle that it was across from, so cosine of 80. Now this is another nice easy one. X is by itself, so plug and chug. I've got x equals 2083 point blah, 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 blah. I store that into alpha A, and then I'm going to take the square root of both sides, and I get x equals 45.6 pounds to the nearest tenth. Now, this one also had a second question, so let's scroll back up. The second question says, find the angle formed by the greater of the two forces and the resultant. The greater of the two forces and the resultant. So I'm going to go back to my picture. So looking at my picture, who's greater, the 30 force or the 40 force? Well, hopefully you're saying the 40, so I'm highlighting that one, and the resultant, and it wants the angle formed in there. All right, so I'm going to redraw that picture for myself. 40, I just found out my resultant was 45.6. And I'm going to finish off, this side was 30, and then we made it look like a parallelogram. And again, I'm just highlighting, I know this side is 40, this side, and I'm looking for this angle here. Do we know any other angle? Well, remember, we found this angle up in the corner to be 80, and if you remember your properties of a parallelogram, if that angle's 80, then this angle's 80. Opposite sides are congruent. All right. So let's see, do we have law of sines or law of cosines? Well, it looks like I've got side and angle opposite, and I've got this angle. Do I know the opposite side? Well, don't forget, you knew this side was 30, which implies this side is 30. So I can do law of sines. Nope. 30 pounds. So I'm going to say the sine of x over side 30 equals the sine of 80 over 45.6. Nice cross multiply. Divide by my 45.6. I get 0.647, blah, blah, blah. I store that into A. Take the sine inverse of both sides. And hopefully you get x equals 40 degrees. All right, I've got one big monster for you here. Gerardo and Beanie are pushing a box. Gerardo pushes with a force of 50 pounds in an easterly direction. And Beanie pushes with a force of 39 pounds in a northeasterly direction. Let's just stop there. We're going to have to draw a picture for ourselves, and let's just figure out our directions. I always said never eat soggy Wheaties for my northeast, southwest, whatever you remember. And let's read this again. Gerardo pushes the force of 50 pounds easternly. So we're going to start here, and he's going to push 50 pounds easternly. And Beanie pushes a force 39 pounds in a northeasterly, so she's kind of between those two. So northeasterly, that's 39. And I'm going to put a G, oops, I think this was Bernie and Gerardo, just so I keep them straight. The resultant force, okay, so that's the resultant's the one down the middle, forms an angle of 32 degrees with a 39-pound force. Whew, let's just stop and read that again. The resultant force, so that's this guy, take your marker and highlight it, forms an angle of 32 degrees with the 39-pound force. So highlight that there. Together, those make the 32-degree angle. Here's our question. Find the angle between the 50-pound force and the 39-pound force. So they're looking for the angle between the 39 and the 50. They want this whole angle in here. Okay? Now, you can't, remember, just say, okay, I'm going to take 32, double it, get 64, and that's the whole angle. Doesn't work that way. The resultant does not bisect that angle. Okay? So that's our properties from geometry. The resultant does not bisect that angle. So I basically have to figure out this angle here, and then I can say, okay, whatever 32 is plus that angle will get me what I'm looking for. All right, so probably the most important thing is just to finish off the parallelogram. And just draw the rest in there. Okay. I also know that this top side is 50. Now, let me pull up another geometry property. This angle and this angle we said add up to 180. But that's not going to help us here because I don't know what x is. So, let me give you another property. You talked about something called alternate interior angles. Does that sound familiar at all? Alternate interior angles. And the easiest way I think about them is a z. And the z usually helps trigger your memory here. What that tells me is in the z, this angle up here and this angle down here are congruent. They are alternate on opposite sides and interior inside your z. So do you see a z anywhere? I'm going to highlight one. I could go like this. And what that would tell me is this angle x down here is going to be the same as this angle up here. So I can put an x here also. Those are alternate interior angles when they make the z and they're on the insides. So here's what I'm thinking. If I get this angle in the triangle, then I'll know this angle and they'll add up to 180. So let's see if we have sines or cosines. I know angle 32 is across from 50, and I know 39 is across from x. So I can go law of sines. So I'm going to say the sine of 32, and the side opposite is 50, equals the sine of x, and its side opposite is 39. Quick cross multiply and solve. Divide by my 50. I've got sine x equals 0.4133. Take my inverse sine, and I get x equals 24.4 degrees to the nearest tenth. So I just need to make sure I answer the question now. To get this whole angle that it wanted here, and again it wanted this whole angle between those two, I'm just going to say 32 plus 24.4 equals 56.4 degrees. Now, was there a second part? I think there was. The next question said, find the magnitude of the resultant force to the nearest pound. All right, I think I need a new sketch. That one's a little messy. All right, so I knew this was 50, 39. I knew this angle was 32, and I just got this to be 24.4. And now they want to know how big is the resultant. Well, I think I can label every side and every angle in this picture. See if you agree. If this side's 50, then this side's 50. I'm going to use my Z, my alternate interior. If this angle's 24.4, then this angle's 24.4. Now think about this. If you know 1, 2 angles in a triangle, can you easily get that third angle? Well, those 3 angles have to add up to 180. So 24 plus 0.4 plus 32 gets me 56.4. If I subtract that from 180, I get an answer of 123.6. So I know this angle is 123.6. Now I think I could probably go law of sines again. I could use this side and the angle opposite, and then I could use either side or angle opposite I want. So I'm going to use this side and this angle opposite and do law of sines one more time to get that answer. So I'm going to say the sine of 123.6 over x equals the sine of 32 over 50. Cross multiply, 50 sine of 123.6 equals the sine of 32 times x. Divide out my sine 32. Now notice this time, I don't have to do any inverse because I already have x by itself. I just get x equals 78.589, and to the nearest whole number, or nearest pound, that gets me, 79 pounds. Well, there you have it. Once you draw the picture, you really just need to determine whether you're law of sines or law of cosines. We look forward to any questions. We'll see you tomorrow.